Okay, so we talked about an index file. There's multiple ways to think about it. There's a way to think about it theoretically as far as computational time. If you give me a list of I don't care how long, let's call it n, can I do something in log n time or the square root of n time or, you know, whatever. This sort of on paper method for getting an answer. And then there's also a physical end to it as far as the data is actually stored on a drive that spins and that takes time to return information. And so you want to reduce the number of times you have to access it. So an index file is a small file that you can load one time, or it reduces the number of times you need to actually access the disk to find what you're looking for. Okay. The second question, is there a way that you can store a data structure like a tree onto physical media like a hard drive? This is, well, there's a couple points here. I don't know. Points of note. A tree is a very efficient computational data structure. Hard drives, memory, and storage devices. Okay, can I make the font a bit bigger? Yes, I can. Yeah. There we go. All right. So is there a way that you can store a data structure like a tree onto physical media like a hard drive? Why would you care to and stuff? I mean, like the highlights are that a tree is very efficient. Like you can start at the top and you can burrow your way to the bottom and find what you're looking for and do it quickly. So that's nice on paper. In the real world, we have physical media that everything is as an array. So that's just what you're stuck with. But this is a way to have your cake and eat it too, where you can take a tree and encode it in an array. We talked about two ways of doing this, the layer by layer method and the pointer method. Either way. Great. Okay. ER diagrams. Let me, oh boy. Okay. I'll start at the top here. So, did I write somewhere what this is? Not really. Okay, I'll start here because I like these diagrams. So, ER, that's an entity relationship diagram. Okay, so entity Okay, so ER diagrams, okay? E stands for entity and R for relationship. An entity, think of it like a table, okay? It's a table with information, lots of different attributes for every entry. So it's some collection of information, okay? Like we have names and, I don't know, address, sex, whatever. And so those are entities. Now, I might have an entity about, let's say, people who have Netflix accounts. Okay? So I have like a collection of information about people who have Netflix subscriptions. Okay, now I also have a collection of information about people who have Amazon Prime memberships. Okay, two different sets of data. Okay, one about Netflix subscribers, another about Amazon Prime members. And I can come up with different relationships between these two. For example, who are the people that have both? Who are the people who have both a Netflix subscription and an Amazon Prime subscription? Who are the people who have only a Netflix subscription and not an Amazon Prime subscription? Or the other way, who are the people who only have Amazon Prime and don't have a Netflix subscription? So these are different kinds of relationships. So an ER diagram is meant to help structure, organize your data in a database, in a relational database. That is, so relations are just tables. And you don't always want to join tables into one big, gigantic table for reasons, but we'll get into that later. In any case, you have lots of disparate data, okay? Netflix subscribers and Amazon Prime subscribers and people who live in this state and people who have that kind of income and whatever. Like all of them, you have all of them kind of together in a pile. And sometimes you want to get results of when they overlap or when they don't overlap. So an entity relationship diagram is supposed to capture the entity that you're talking about. What exactly is this collection of information? And the relationship is how exactly these two separate entities connect with one another. Like according to what? And that's the relationship. So, for example, Netflix subscribers and Amazon Prime subscribers, you could have different relationships between these two entities. You could have the relationship where the person who's a Netflix subscriber is also the same person who's an Amazon Prime subscriber, or a different relationship would be, who's a Netflix subscriber that doesn't subscribe to Amazon Prime. So you can have different relationships, but there's a reason why these entities are separate, why they should be kept separate. So having this, an entity is going to basically be like a table. An entity is a table, it is a relation. And if you're comfortable with the idea of a table, it will make things easier if you're comfortable with me also calling it either an entity or a relation. Okay, so an ER diagram, that's an entity, that's a relationship. And the diagram itself, an ER diagram, is a fixed set of rules to define trying to come up with a good phrasing of this. Okay, so a fixed set of rules to define the connectivity between entities. And what I mean by connectivity is that if we have some set here with 3 points, and we have some set here with 2 points, we could define connectivity meaning one to many. So one point can connect to many points. That's a one to many. We could have a many to many, in which case you can have this, a one to many, on one side, and then you can also have a one to many on another side. So now this is a many to many. There's also a one-to-one. One-to-one means that one has to match up with one. Let me pick on a random person. How about Junan? Junan, Junan. Something like this. No? Okay, then let's go on to Nicole.
Hi.
Hey. Have you heard about these kinds of relationships before between sets? One to many, many to many, one to one?
Yeah.
Yeah, okay.
Yeah.
Okay, so here in the screen, I'm going to mark them A and B. If these are two sets, A and B, is there a one-to-one relationship that I can make between them?
No, you can't because there aren't 3 different values for B. So there's not going to be exactly 1 point in A connected to 1 point in B. There will be one left over in A.
Very good. Excellent. Thank you very much. Okay, so that's exactly right. So this type of example, a one-to-one relationship, means that every element in A has to be matched with some element in B, a unique element. The unique element, that's not a requirement, it's a consequence. Whatever. But for example, with these two sets, there's no way for them to have a one-to-one relationship, because if we want this element in A to connect to one in B and another one to connect to another one in B, we have one left over, as Nicole very correctly pointed out. Okay, so these are the kinds of relationships, okay? It's going to be useful to be able to shift perspective into different ways. Sometimes it's useful to think of things as sets, other times it's useful to think about things as tables. They're actually both, and so that's why it doesn't matter how you think about it. But okay. Great. So this is the vocabulary for ER diagrams. Entities are a rectangle, relationships, and okay, so an entity is a rectangle, and off of this rectangle, as we see here, there's an example of an entity. Off of this rectangle, there can be these ovals. Some ovals have an extra property where one of them is underlined. Okay, that makes it a key for that entity. A key means that it's a unique identifier for that entity. So if you have a table of different things, there has to be some way that you can describe every entry of that table. That could be a unique column, like a name or a social security number or a user ID or whatever, or a combination of things. But there has to be some sort of unique thing to identify everything in this entity. So that's an entity, a rectangle, an attribute that entities can have, a keyed attribute. By the way, relationships can also have attributes. So I'll just do that. They don't need to be a keyed attribute, though, for relationships. Entities need at least one keyed attribute. Okay, so those are entities. Okay, so an entity, again, think of it as a table. So this entity E1 would be a table named E1. It has two attributes, A and B. So therefore there's two columns, A and B. A is the keyed attribute, which means that A has to be some unique identifier. Maybe I think about it like a social security number. It's some unique thing. Okay. Let me use a different one here. All right. So the next thing about ER diagrams are these four arrows, or these four lines. So we have thin lines, thick lines, thin arrows, and thick arrows. I should mention that if you've been exposed to ER diagrams before, that's fine. The ER diagrams that I'm teaching in this class are the ones that come from this book. It's the same thing as far as the ER diagrams go. It's just a different notation. I'm using a particular notation here. Other ones that you might see would have things like, I don't know, lines like this, or, a line with a number, or something like that. Whatever. So the ER diagrams that I'm teaching are based off of this book that's on our course syllabus that you can also use as a reference for this course. You can also find a free PDF version of it online. So, is there a relationship many to one? I see a question. Yes, and very good. So there's a one-to-many relationship, many-to-many, one-to-one, and a many-to-one. A many-to-one relationship could look something like that. So we have many going to one. And the distinction is important because a one-to-many versus a many-to-one is very much like the difference between Amazon Prime subscribers that are not Netflix subscribers and Netflix subscribers who are not Amazon Prime subscribers. Like those could be two different sets of people. And so that's the kind of difference that a one-to-many or a many-to-one relationship can kind of work. Okay. So for these lines, okay, so let's imagine that this thing on the left is Amazon Prime subscribers, and the thing on the right is Netflix subscribers, and the relationship we want to know about is has both. And, you know, here I could, so for example, a relationship could have a since. This particular relationship is asking when or who are the people that have both a Amazon Prime subscription and a Netflix subscription, and since when did they have both? Right, so maybe they had an Amazon Prime subscription for a really long time, and then now they just got Netflix all of a sudden, and so that's what I'm trying to capture with this since attribute. Okay, so like that, it makes sense to have since. Okay, I'm falling down a rabbit hole. That's an example of why you would give a relationship an attribute. Okay, it's not only that these things have some commonality, that is that, for example, the social security number of the person with the Amazon Prime subscription is equal to the social security number of the person that has a Netflix subscription. But also there's a point in time when that thing became true. So that's the point of having an attribute off of a relationship. Okay. So let's say that these are social security numbers. It's not cool. It's not the way it actually is, but for the purposes of this lecture, let's imagine that both Amazon Prime and Netflix both have your social security number. Now, here, Prime, for whatever reason, your social security number, they call that A for Amazon. And Netflix calls your social security number D for, I don't know, you fill in the blank. Let's see, is that what I want to say exactly? No, I think I want to say something more general. Okay. I'm going to say something a little bit more general. Amazon Prime keeps your social security number because, I don't know, there's one of its devices listening in every room of your house. And so they call that A for Amazon. Netflix has your home address. And so that's how they uniquely identify you. No, that's not going to work. Okay. I'll do it this way. We'll keep this one easier. Okay. We're in, I'm sorry, I don't know if you've looked around or like noticed anything, but like we're in a dystopia. Okay? And so in this dystopia, not dysutopia, dystopia, both Amazon and Netflix know everything about you, and they have your social security number that they both call A. Now, some evil overlord now wants to know who has both Netflix and Amazon Prime. The way that they can find that is by taking these people that have Amazon Prime and these people that have Netflix accounts and putting in here the ones that match. So, matches. So that's a relationship. And this would also have since, a column for since, actually. That should not be underlined. Okay. Okay. Now, I want to go deeper, but before I do, I'd like to pause and open the floor for questions. Points where I've completely lost you, where you've learned something before that's different than what I'm saying now, or anything like that. There's no way that everybody's following me. I don't believe it. You can message me privately if you like, but there's no way I can talk for that long. Okay, great. Private messaging. I wonder how, when the world gets back to normal, yeah, it's kind of nice having students just like, I don't know, send you a, anyway. Okay. Can I re-explain the since thing? Okay. So in these things, ER diagrams, okay, they're made up of two things, mainly, entities, E, and relationships, R. So an entity, we'll make it like a box, and this is going to be like a table, and we can name the table like Prime. So these are people with Amazon Prime subscriptions. Meanwhile, I'll also draw kind of a mental picture of, so far we have a table called Prime. Now, because we're living in a dystopia, they know your social security number. And so therefore, there's going to be a column, social security number, and I'm underlining it, which means that it's unique. Okay, no two entries with the same social security number. That's not allowed. Okay, besides that, they know your name, your address, and your greatest fear in life. Okay, so those are the things that Prime knows about you. And so therefore here there would be a name, an address, here, and okay. That's as much as as the entity tells you. The entity tells you the name of the table or the relation, what the key is, that's the unique identifier, and other attributes that can exist. Okay, that's what the entity does. The entity doesn't care about the specific entries here. Okay, like that's too detailed for what the entity is capturing. The entity is only capturing the kind of layout of the table. Okay. Now, let's say that Netflix is another entity, and they also know your social security number, as well as your name, and I don't know. I'll say least favorite movie. Okay. All right, so that's what Netflix knows. Okay, so now Netflix is going to be another table where there's information. Every entry of this table is going to have a unique social security number. It's unique because I've underlined it. Okay, there's also going to be a name and worst movie. Whatever. Okay. The relationship. I'll do a different relationship than before. I'll say leave a nice one, actually. Okay. Okay. So I'm going to come up with this kind of relationship. There's these people with Netflix accounts. There's these other people with Amazon Prime accounts. I want to know the ones that share accounts with a household. Okay? So there's a few different kinds of connections that I'm okay with. It could be a single person. And here's that same single person. All right. Now here's a guy, John Doe, who has both an Amazon Prime account and a Netflix account, and he's a lonely guy. He's his own household, so he's in. Okay, I'm counting the number of people who share accounts within their household. Now, there's a different kind of person. This is I don't know, Barbie and Ken. And now they are two different people. And Ken here. Ken is the one with a Netflix subscription, and only Ken uses the Netflix subscription. But for the Prime subscription, they both like Prime. They both order stuff and get it delivered to the house and whatever. Barbie's lame and doesn't like movies. So here we could have this type of relationship. This is a many to one. Many to one. Okay? There's people who have a Prime subscription. There's other people who have a Netflix subscription. Some of those people share their Amazon Prime subscription and then don't share their Netflix subscription. But I'm counting the people who have both and who share one or the other. Oh, now here's another question. Why wouldn't it also be one-to-many relationship the other way? So a one-to-many relationship the other way is a many-to-one. This is a many-to-one. Let me do a one. Oh, I'm sorry. Actually, no, you're right. That there could be. Let's see. What's another couple? Okay. We'll do Al and Peg. Okay. So this is a couple that shares a Netflix subscription because they both like laying around and watching Netflix, but also enjoying Netflix on their own time, which is why they pay one fee but have separate accounts. Whatever, they share a Netflix account. But Al is super old-fashioned, and he only, he likes supporting local businesses and walking there. But Peg likes to have things delivered, and so she's the only one with a Prime account. So that would be like this. This would be a one-to-many. And yeah, sure, great. Let's count them too in this relationship. I think that they should be counted. But you see, you can go through this and say, in each direction, is one connecting to many? Can many connect to one? Does it need to be a one-to-one relationship? For every single entry in this table, should there be a corresponding entry in another table? That would be a one-to-one relationship. Of course, you can make it however you like. It depends on what you're doing. And that's the point of an ER diagram. Here I'm drawing many lines. Let me think if there's a way that I can do this. No, everything's going to be messy. Okay. Well, so I'm sorry, I'll just do it this way. So for this example, we're saying that there can be single household people, and we want to count them as sharing their account with themselves. We also want to count people who share their Prime account, even though only one of them uses a Netflix account, and vice versa. So that means here, that's going to be a let's see. I'll make it a thick line. Okay, this is going to be a little hard. No, not hard. Okay, so in this example, we have 4 people with a Prime account on the left. We have 4 people on the right with a Netflix account. They're not exactly the same 4 names, but whatever. Now, in this example, every single person with a Prime account also has a Netflix account. And vice versa. Well, or every... no, that's not right. What it happens to be is that there's what's called total participation. What total participation means is that it is not allowed that here you have Jane. Jane has a Netflix account, but nowhere in Prime. There's no connection between Jane and this relationship. Okay? If this is allowed, then this would be an unconstrained relationship, a thin line. Okay, just pay attention to the pink part, I guess. So a thin line would mean that this is okay. It's okay to have members of this entity not participate in the relationship. That's what a thin line means. A thin line is unconstrained, so anything goes. Okay, no participation, total participation, partial participation, whatever. If it's a thin line, then anything goes. So for example, here, Jane having a Netflix account and there being nobody that Jane is connected to with a Prime account, if we're okay with that, then we could identify that with a thin line. Now, on the right side, we could do this. Make that a thick line. This is also okay with what we have, because there's a difference. There's both a left side and a right side, and all the time you have to consider the relationship going both directions. So here, what this is saying, if there's a thick line on the right, which means at least one, and a thin line on the right, which says anything goes, that means Jane here, who's not connected to anybody with a Prime account, she's still okay. No problem. Because it's a thin line. Anything goes on the right-hand side of this. But if you had a Skip here, he would not be okay, because this is a thick line, which means that everybody has to participate at least once. Okay, let me pause there and review some questions here. Can a Netflix bar be plus Canon? Oh, I see. Okay. Yeah. Okay. So here, to emphasize, there's a difference. And right now, only pay attention to the pink lines, okay? That is a thin line versus a thick line. A thin line means that the way that each of the points here, this point, that point, this point, this point, this point, how are all of them participating? Now we have 4 out of 5 that are participating in this relationship. So because it's a thin line, this is okay. There's no problem with that. But on the right, with skip, this is not okay because it's a thick line, which means that everybody has to participate at least one time. Okay. Can I explain the pink line? Okay. So, all right. Sorry, I was trying to save space, but okay. So that's it. It's the difference. It's this. Sorry. Okay, so that's the format of what I'm trying to describe on the left with the pink lines. This is a thin line, which means that there's entries in here that might not participate in this relationship, and that's okay. But here, because it's a thick line, that means that every single point inside of here must, at least one time, be connected to this relationship somehow. So that could be this sort of many to one or one to many, whatever. Yeah, everything here has to participate at least once. If you were to have a point like this, then it's not connected to anything, and that's not cool. This is not allowed because this is a thick line. Here, you could have all empty points. I don't know, I'll connect one or a couple just for fun. Okay. Like here, all of these points are okay. Okay. Scroll up here. Just to clarify, Alpeg and Ken Barbie counts as one entity, right? So if there's at least one of them on each side, it works. No. Oh, and by the way, let me get rid of these. Again, for the pink lines on the right, or on the left, excuse me, that I'm going to scroll over to in a minute, what I was trying to convey is there being one thick line, so there's going to be a thick pink line, and then a thin pink line, okay, to differentiate. That is different than that. The way that each of these entities participate in this relationship is different. So as a concrete example of that, I'm going to go back to the left, and again, there will be a thin pink line and a thick pink line. I'm just trying to convey this. Okay, so there's our thick pink line and our thin pink line. Now, there was a question about entities. So an entity is this whole thing. That whole thing's an entity. So an entity also has attributes and all this stuff. Now, when we're talking, hold on, let me read this question exactly. Al/Peg, Al and Peg, and Barbie and Ken. These count as one entity, correct? No. These are not entities. An entity is this whole thing. Otherwise, you can think about an entity like this. The name of the table and the name of the columns. This does not concern itself with the particular entries. An entity does not do that. A relationship does concern itself with particular entries, but not explicitly, implicitly. So by implicitly, I mean that let's see here. I'm going to click thick again. By implicitly, that means that these points aren't actually points that exist. They're just sort of things that I'm thinking about as far as who do I want to count when I'm saying shared accounts with households. I can go through different ways of phrasing it and say, yes, that group I want to count. No, that group I don't. What this is saying right now is that single households, do I want to count them? Yes. How about multiple people with a Prime account, even though one of them has a Netflix account? Yes. People who share a Prime account and they share a Netflix account? Yes, that will also be true here. How about people who just have a Prime account, or only one of them uses a Prime account, but they share a Netflix account? Yes, count them as well. Okay, but now for some reason, because I decide to, I want to exclude certain people from the count. That is, I'm fine counting people who only have a Netflix subscription, but I'm discounting people who only have a Prime subscription. So that difference, and for whatever reason, it's because it's how I feel, it's what I want, then the way that you can capture that in a diagram is like this, where you say, okay, so here, only people, like they have to have a Prime account. But whether or not they have or whether or not, yeah, the Netflix account holder also has a Prime account holder, I don't care about that. Generally, it takes, 6 to 8 questions of who you want to count. What happened here? Okay. Why 6 to 8? So here, you have to ask yourself, what's the relationship going this way? That's here. Okay? So if this is Prime, and this is Netflix, and this is shares, going, one, you have to consider this way, which is the people who have Prime accounts, or the people who share Prime accounts, do they have a Netflix account? Okay, that's one group of people. People who share a Prime account, and they also, at least one of them, has a Netflix account. There's another direction, which is a little different. This is people who share Netflix accounts do they also have prime accounts? Okay, so you have these two sets of data, and there's different ways that you can consider what you want to count and how. And this has two directions between every entity. This is an example of those two. And then you can nuance it a little bit more by thick lines, thin lines, arrows, saying that every member of this has to participate at least, one has to participate in at least one, maybe many, or maybe everybody can only participate exactly one time. Okay, and so this is, what ER diagrams are doing at a high level. Okay, they're not just pretty diagrams. It's a way to very clearly specify who you want to count, who you don't want to count, and then there's a fairly simple way to figure out how to construct tables for this. In particular, how to construct them for relationships. We'll talk about this next class. For entities, it's very straightforward. I mean, I've already done it here. I mean, there's an entity, here's an entity, and that's what it looks like as a table. Pretty straightforward. The relationship is can be a little bit more complicated. Okay, so we're coming up on 3. I will pause, or I'll finish up now and let you guys log off if you like. I'll hang around if there's any questions.